Hello everyone, welcome once again to the part 2. Now in this section also we have a discrete variable question, but then it's just a bit different from what we did with the part 1. So it's still a discrete variable. So we are given this table s values and then with their respective probabilities, and then the question says that if h of s equal to 20 plus 3s plus 0.5s squared, we should find the expectancy of h of x. So in this case we are still calculating for the expectancy, or the mean in this case. Alright, so let's quickly look at how we would have to do this. Now before that, this function is a PMF. Why? Because it satisfies these three equations again. So we have the summation of p of s should be equal to 1, and then we sum 0.55 plus 0.725 is just 0.80, and then plus 0.20, which is just 1. So it satisfies this, and then also our probability should be greater or equal to 0, which is within the range, and then also it should be within this range, which is between 0 and 1, which satisfies all three equations. So therefore it's a probability mass function. So now the question is we should find the expectancy of h of s, where we are given h of s. So in this case, expectancy h of x here is equal to expectancy of, now we have to replace the h of s with whatever we are given. So we have 20 plus 3x here plus 0.5s squared in this case. Now with the expectancy, or with any expectancy or variance, well, anytime we are multiplying them by a constant, we are only interested in they are only interested, or they make emphasis on the variable x, or whatever, the variable x. So whereby they consider all other values there as constant. So in this case, you multiplied by that is just a constant 20 on its own, and then also we have e to that, so it takes the constant 3 outside, and then it's considered the expectancy of x. In the case of variance, if it were to be a variance, we would have to square the 3 here, and then we have the variance of s, and over here too we'll square the 20 here. Then but in this case we are doing expectancy, so in this case too we have 0.5 here as a constant, and then the expectancy of just the s squared in this case. So now for us to get this, we would have to calculate that. So we need expectancy of x. Now what is the expectancy of s? Expectancy of s is just the summation of s, and then the summation of the product of s and that of p of x. So in this case, our x, we add to be so in the first case we have 4 here multiplied by 0.5, 6 here multiplied by that, so that's what we are going to do. Then we sum them. So we have 4 multiplied by 0.55 plus 6 here multiplied by 0.25 plus 9 here multiplied by 0.20. So in this case, when we find the product and sum the whole of that, we should get our e of s, which is the mu, to be 11/2, which is equal to 5.5 in this case. Now what do we need again? We need e of s squared. So in this case we have e of s squared here, So in this case we are squaring the s value. So we have 4 squared multiplied by 0.55 plus 6 squared multiplied by 0.25 plus 9 squared multiplied by 0.20, and then when we compute the whole of that, we should get this to be equal to 34 in this case. So since we have our e of s and that of e of s squared, then we can calculate the expectancy of h of x. So we have 3 e of x here, and then plus 0.5 here, and then e of s squared here. So we have 20 here plus 3 multiplied by e of x, we add to be 5.5, which is 11 over 2, plus 0.5 here multiplied by our e of s squared, which is just 34, and then computing the whole of that, we should get the whole of that to be 53.5, and that is going to give us the expectancy of h of s in this case. So that will be it for today. Thank you very much, and then I'll see you guys in the third part, and that will be the final part on discrete variables, and then from there we'll do something on random variables, on continuous data or continuous variables. So thank you very much, and I'll see you guys in another section. If you are new here, please like, subscribe, and also hit the notification bell to be notified anytime I post a new video. Thank you very much, and I'll see you guys in another section.